Hello everyone. Today let's solve the problem number 146 LRU cache, right? So here you can just go through the question and you can try to understand the question with the help of example that they have given, right? So I'll just summarize the question for you so that it will be easier to understand. So what the question states here, the problem requires designing a least recently used cache, nothing but LRU cache. LRU cache is nothing but least recently used cache. We have to design the least recently used cache. So this is a data structure that maintains a limited capacity. So it will be having the limited capacity and ensures that one thing is, if the cache reaches its capacity, then the least recently used key value pair is removed when a new pair is added. This is important. Just listen to this again. This is a data structure that maintains a limited capacity they have given, right? Least recently used cache maintains the limited capacity and it ensures that if a cache reaches its capacity, then the least recently used key value pair is removed when a new pair is added. This is first condition or the first requirement. Second requirement is the get operation retrieves the value for a given key if it exists and marks it as the recently used. So we can retrieve or we can get the value from a particular key using the get operation. Then what does the put operation? So here you can clearly see we are having two operations here, two methods, right? One is get and one is put. This is for the initialization. This is initialization part. So we have discussed about the get, nothing but we can retrieve the value of the given key if it exists by making use of the get operation and it marks it as the recently used. So what does the put operation do then? Put operation adds or updates a key value pair and it also ensures the capacity is maintained. Again, I'm telling the put operation, this is important, adds or updates a key value pair and it also ensures that the capacity is maintained. I hope this is clear. So what are the key points here? The cache must operate in big O of one time complexity. That's what they have given here. Must, the function get and put must each run in big O of one average time complexity. They have strictly mentioned this one. So we have to keep this one in mind. The cache must operate in big O of one time complexity for both get and put operations. So how can we do that? While we have to deal with the key value pair, we strictly know this, we have to deal with the key value pair. So let's go with the hash map and also let's make use of the doubly linked list, right? So why we can achieve the big O of one time complexity by making use of maps. We know that for the lookups, the time complexity would be big O of 1, right? And the doubly linked list also for the insertion and the removal of the elements in the order of usage, it will be big O of 1 itself. So let's go with the this one, hash map and the doubly linked list approach, right? And one more thing, JavaScript's map already preserves the insertion order. We know this one. So this will be let's take advantage of that one, right? So let's initially discuss the approach. Then let's dry run the example that they have mentioned in the example. This one. Let's see this one. LRU cache of 2 they have given here null because here whatever null they have given here, because one more thing we have to keep in mind here, they have strictly given here this one, the return value of this one will be null and also the return value of the put is also null. Here you can clearly see return void they have given, nothing but null here. Only the return value of the get is number here, right? So only the return value of the get is number and the key and the value also they have given number here. So the return value of the get method is number and other two things, initialization and put. So the return value of these both will be null. So this one we have to keep in mind. So here return value of LRU cache here, this one will be null initialization. Put we know null, put we know null, get we have got the value 1 here, this one itself 1 and put again here null we have got, right? So here again get this will be 2, this one we have got the output -1. So we will see this one. I just wanted to show how we got the null here. we will see how we got -1, 3 and 4 basically while we dry run this one example step by step. They have explained here as well, so you can just see this one. So here they have clearly mentioned here cache is 1 here. This one cache is 1. But this one, let's see while we run the code, so you'll understand this one pretty better, right? So I hope this is it. Let's start the approach first. So let's discuss the approach step by step. First thing is, as we have discussed this one already, we will be making use of hash map and doubly linked list, right? So this will be hash map and doubly linked list. So the first step here is this one. We know that map maintains the insertion order. So the recently used item will always be the first item. That is the reason we'll be making use of the hash map. We have already discussed this one, right? And let's discuss this one step by step. First one is we have the put method in the question. Put and get method we have, right? Put of key and value they have considered. So what we'll be doing here is if the key already exists, so I have already said that in the put we'll be adding the element or updating the element based on the key, right? So we have key and value here, and in the get we will retrieve or we will get the value based on the key. Then only the parameter that we need to consider in the get is key, but in the put we'll be having the key and value, right? So let's see what we'll do in the put. If the key already exists, then we will remove and update its order. So if the key already exists, then we will remove and update its order. If adding the new key, this one, whatever, if suppose if we add the new key, if it exceeds the capacity, then what we will do? We will remove the most or least recently used item. Sorry, not the most. We will remove the least recently used item. Nothing but the first item in the map. We will be removing the first item that is present in the map, which will be recently used, least recently used. So this is important. And finally, we will add the key value pair to the map. After performing that one, we'll be adding the key value pair to the map. This is what we'll be doing in the put. So let's move on with the get here. So in get method, what we'll be doing? We'll be having only key, right? So if the key exists, then we will retrieve the value based on the key here. So I can just write here get of key. If the key already exists, then we will retrieve the value from the key. Retrieve or get the value, right? Retrieve or get the value based on the key that we have. So this is one thing. And reinsert it. So we have, after doing this one, we have to reinsert the key. Why we have to reinsert the key? Because we have to mark it as recently used, right? So that is the reason we have to reinsert it, right? This is one thing. And finally, if the key does not exist, we are returning -1. This is important. If the key does not exist at all in the get method, then we are returning -1. So I hope the approach is completely clear. This is what we'll be doing in the put and get methods, and also the approach that we have discussed. We'll be going with hash map and the doubly linked list. So next, let's dry run the example that they have given in the question so that you will understand the concept very clearly. So then we'll be discussing the edge cases one by one, and then let's write the code, and finally let's discuss the complexities of the code that we have written. So the next step is let's dry run the example that they have given in the question. So let's discuss the example that they have given in the question. This is the example that they have given in the question, right? So let's see this one step by step. So first thing here is, I'll just come here. Let's consider the LRU cache of 2. Nothing but this one. We are considering LRU cache and we are considering this one 2, right? I'll just consider here operation. First one will be, this one will be first one. operation will be LRU cache of 2 here. This is fine. And new cache will be created with the capacity of 2 here. So new cache will be created with the capacity of 2, and the cache will be initially this one, empty, right? This will be empty at this point. The output will be, so the output will be null here. For this one, for the first one, the output that we got here is null, right? Next, let's consider put and 1 comma 1 here. Let's move on with the second operation. So here, the second one, operation we are considering here is put of 1 comma 1 we need to consider here, right? So we are adding a key value pair 1 equals 1 to the cache here. So here we are adding the key value pair 1 equals 1 to the cache. Then now the cache is, what the cache consists of here? We now know this will be 1, and output will be still null. Why? The return value of the put is null. I have already said this one multiple times. The return value of this one put is null. Initialization and the put is null. Only the return value of the get is number. So the output will be here null. Let's move on with the third operation. So here, let me come here. Let's consider this one now. Put of 2 comma 2 here. So let me come here. Operation, let's consider put of 2 comma 2 we have. So a cache will be now, we already have 1 comma 1 equals 1 in the previous one. So now it will be 1 equals 1 and 2 equals 2. So both items are within the capacity. So still the output will be null. Why? The return value of the put is null. So the output will be null, right? Let's go with the fourth operation. Nothing but here in this case, they have mentioned get of 1. We need to consider get of 1, right? So let me come here. This will be, let's consider operation get of 1 here. This is fine. So the key 1 exists in the cache. We are dealing with a get, not put, right? We can just retrieve the value based on the key in the get. We have already discussed this one. So the key 1 exists in the cache. We know this one. So return its value 1. So we are returning the value 1. We already have the key 1 that exists in the cache. So we are returning the value 1. Here, this one we are speaking of key 1 we have. So we are retrieving the value 1 from that key. So we are returning the value 1 here. So we are marking this 1 as most recently, just give me a second here. We are marking 1 as recently used by reinserting it. So we are marking this one as recently used, right? And we are reinserting it. We have already discussed this one. We are reinserting it to remove and re-adding it to the map, right? So now what will be the cache here? Now the cache consists of 2 equals 2 and 1 equals 1 in this order, right? Now 1 is the most recently used one. This one is the most recently used, and 2 is the least recently used. Now before this one, 2 was the most recently used, right? So here now 1 is the most recently used and 2 is the least recently used. So the output will be here when we retrieve, this is 1. So this is the most recently used. So the output will be 1 here in this case. So let's move on with the fifth step. So here, let me come here. Fifth one, we have to consider this put and 3 comma 3. Put of 3 comma 3, right? So let me give you operation put of 3 comma 3, right? So we are adding the key value pair 3 comma 3 to the cache. So we have this one, right? we have to add this one. We are adding this one to the cache. 3 equals 3 to the cache. Now the cache is full. I mean, capacity is 2 itself, right? Now the cache is full. So we have to evict the least recently used key. Nothing but we have to evict 2 here in this case, right? So now the cache is full. Nothing but capacity equals to 2, right? So we have to evict the recently used key, nothing but 2 here. So cache after the eviction will be, we have 2, this one 2 comma 2. So this one was full, right? Capacity was full. We will be removing this one, and now only this one remains, right? So let me come here. So now the cache after eviction will be 1 equals 1. So cache after adding 3 equals 3, it will be, cache will be 3 equals 3, and sorry, just give me a second here. This will be 1 equals 1, and also 3 equals 3. In this way we can write here. So output will be again null here, because we know the return value of the put is null. So the output will be obviously null. Let's move with the 6th step, nothing but the 6th operation here. So let me come here. 6th one is get of this one 2, right? So let me come here, get of 2. Let me give here, sorry, just give me a second here. Let me give here operation get of 2 here in this case, right? So the key does not exist in the cache. Here you can clearly see in this step 2 was evicted, right? 2 was evicted in the previous step. We know this one. 2 was evicted in the previous step. We don't have the key 2, right, in the cache. So we don't have, as we don't have the key 2 in the cache, we will be giving the output -1. We have discussed this one in the approach already. So let's move on with the this one, next step here, 7th step. So in the previous step the output will be -1, as the key does not exist in the cache at all, because in the previous step it was evicted. So let's come to the this one example. Next step will be put of 4 comma 4 here. Let's consider here put of 4 comma 4, right? So let me give you operation put of 4 comma 4 here. In this case what happens, we are adding the key value pair 4 equals 4 to the cache. So here you can clearly see 4 equals 4 to the cache. So now the cache is full, nothing but capacity equals 2, right? So we evict the least recently used cache. Now we have actually, while we add, it will be 4 comma 4 and 1 equals 1, right? So we evict the least recently used key, nothing but 1. We will be evicting this one, or we will be removing this one. Cache after eviction will be this one. We have 3 equals 3 as well, right? Sorry, it will be basically just remove this one. Yeah, this one will be 3 equals 3. So cache after eviction it will be 3 comma 3. So after this one we'll be adding. So just ignore this one. So cache after adding 4 comma 4, we are adding the 4 comma 4, right? So it will be 4 equals 4 equals 4 and 3 equals 3. It will be, cache will be here in this step 3 equals 3 and 4 equals 4. So the output will be still null here, because we know that the return value of the put operation they have given void or null. So this is the 7th operation or 7th step. Let's move on with the 8th operation. So here let me come this one. We have 3 gets, right? So here get of last 3, get of 1, get of 3, get of 4. So here let me come sorry, here operation will be get of 1. This one will be get of 1 here. So the key 1 does not exist in the cache because we have previously evicted the 1 from cache. You can clearly see we have evicted this one from the cache. So now the key 1 does not exist in the cache. So the output will be -1 here in this case. So let's move on to the next operation. Nothing but get of 3 and get of 4 we have, right? So the last two. Here it will be get of 3 here. So here the key 3 exists in the cache. So we are returning the value 3. You can clearly see here. Key 3 exists. 3 and 4 exists, right, in the key. Now, only 1 was evicted from the cache. So now we have 3 and 4. Key 3 we are having, exists in the cache. So we are returning its value 3. We are marking 3 as recently used by reinserting it. Now the cache will be same thing. Cache will be 4 equals 4. 3 equals 3 here. Now 3 is the most recently used and 4 is this will be the least recently used and this will be the most recently used cache now, right? So the output will be here, in this case will be 3. We are dealing with least recently used cache, right? So now the output will be quite obviously 3. So let's move with the last operation, nothing but get of 4, right? Operation, this one, the last one, get of 4. Let me check this one. Yeah, get of 3 last, we did last operation. This one is the final operation, get of 4 here. Just give me a second here. Get of 4, the final one. All right. So the key 4 exists in the cache. We can clearly see here the key 4 and 3 exists in the cache. The key 4 exists in the cache. So we will return its value 4 here. We will be marking the 4 as recently used by reinserting it, this one 4. And finally we are having the cache now. Cache will be 3 equals 3 and 4 equals 4. In this step we are now 4 is the most recently used, this one most recently used, and 3 will be the least recently used, right? So the output will be 4 here. In this case the output will be 4 here. So what output we got here? Let's see what output we got here. Null, null, null and 1, 2, null, -1, null, and finally -1 and 3. -1, 3 and 4, right? So the output that we got here is, just give me a second here, null, 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 1, again null due to put operation here, and -1. We didn't have the key at all. It was already previously evicted. Again null, -1. Finally we got 3 and 4. This is the output that we got. This matches with the output that they have given in the example. So the approach works absolutely correct, right? So I hope the example is completely clear. Next, let's discuss the edge cases step by step, and then finally let's write the code and discuss the complexities that we have for the code that we have written. So now let's discuss the edge cases step by. So let's discuss the edge cases one by one. First one is empty cache. So while I say empty cache, let me consider the input. For example, let me consider here LRU cache here, and let me consider get here in this case, right? This is fine. And let me consider and this one 2, and this one let it be 1 here. So as the cache is empty, this one, the output will be here -1. This is fair. And second one is for overwriting values. Here let me give overwriting values, right? So in this case here we can call put with an existing key to update its values, right? We can just call the put method with an existing key to update its value. Example, let me consider here put of 1 comma 10 here. Basically we are just updating 1 here, right? If put 1 comma 5 was done earlier in this case, here it updates 1. So here I can write here in this way, it updates 1 if put of 1 comma 5 is done earlier. So if you are not understanding this one, please just go through the example that I have explained step by step. You can visualize in the same way. So let's move on with the third edge case, nothing but the capacity overflow here. While I say capacity overflow, let me consider the input put of 3 comma 3. So we have to ensure that the recently used key is evicted, right, when the capacity overflows. So here I have given put of 3 comma 3 after the capacity is reached. I hope these three edge cases are clear, right? First one we went with the empty cache, second one we went with overwriting values, and third one we went with the capacity overflow. So I hope all the edge cases are clear. Next, let's start writing the code, and I'll explain the code while we write the code itself, and finally discuss the complexities of the code that we have written. So let's start writing the code here. So let's do one thing. Instead of using the methods here, functional way of writing, let's make use of class here, right? So in the function, we'll go with the initialization, get and put method, right? In the class, we'll just go with the instead of for the initialization, we'll be going with the constructor, and finally get and put method, same, right? So we haven't made use of the class yet, right? So in any of the problems, let's make use of the class here. I'll just give here LRU cache. So this one is fine. For the initialization, let's go with the constructor here. Constructor of C they had given, right? So what we'll do here, we are making use of the constructor just to initialize the cache. First, let's set the cache capacity. So I'll just give here this dot capacity equals, let me give you capacity. This is fine. We are just setting the cache's capacity. Next, we have already discussed that we'll be making use of the hash map, as we have to deal with the store. As we have to deal with key value pairs. We have to store the key value pairs, right? So that is the reason we'll be making use of the hash map. So I'll just give here this dot map equals new map. We are just creating the map here. So this M has to be capital. This is fine. So next, we had this one get method. So let's go with the get initially. So we have discussed this one in the approach. If key is not in the map, then we have to return -1. So if key is not present in the map, we can articulate in this way, right? In the form of code, we can just write here, if this dot map dot has of key here, or key, let's consider key instead of it will be meaningful actually. So this is fine. Key, then I'll just write it here itself. Then let's return -1. So we have to get the value associated with the key, right? So how can we do that? I'll just give here b equals this dot map dot get of key here. This is fine. And we have to remove the key value pair to update its order, to update the order of the LRU. So we have to remove the key value pair. For this one, we'll be making use of the delete operation in the map, hash map. I'll just give here this dot map dot delete here of key. This is simple. Next step is we have to reinsert the key value pair to mark it as recently used, most recently used and the least recently used. We have to reinsert the key value pair, right? If you have observed the example, you'll be knowing this one. So this one map, while explaining the example, we had went through this one itself step by step here. So this one will be map.set key and value. So let me give here, instead of v, let me consider here value. This would be more meaningful here. So this is fine. Finally, let's return value. So after reinserting the key value pair to mark it as recently used, we have to return the value as well. This is it for the key. Next, let's go with the put operation or put method here. This consists of key and value. We are just adding or updating the value based on the key here, right? That's what we have discussed in the approach here. Put, what shall we do here in the first step? If key already exists, then let's delete it to update the order. So how can we do that one? If start map has of key here, then what we will do? If the key is already present, we have to delete it to update the order, right? So for deleting, let's make use of the delete operation in the map. I'll just give here delete of key. This is fine. And the second step is, if capacity is full, if the capacity is already full, then we have to evict the least recently used key. This one we know. Again, I'm telling, if the capacity is full, then we have to evict or remove the least recently used key. How can we articulate this one in the form of code? This one we can just give here else if this dot map dot size, if it is equal to the capacity, then we can delete by making use of the delete operation in the map. So I can just write in this way, sorry. This one, this dot map keys next dot value. So what we are doing here, I have already said this one. If the capacity is full, we are just evicting the least recently used key. The final step is we have to add the key value pair to the cache, right? So let's add this one. This will be the final step. This is simple, right? We just have to add the key value pair. We'll just make use of the set operation, the hash map, and I'll just set this one to key and value. Nothing but we are just adding the key value pair to the cache. Let me format this code once and let me hit the run button. So we are getting runtime error capacity. Oh yeah, I have considered C here. Let me give here capacity. So let me hit the run button again. So you can clearly see the sample test case is getting passed here. So let me hit the submit button. So you can clearly see all the test cases are getting passed here. So the code works absolutely correct. Let's quickly discuss the time complexity and the space complexity of the code that we have written. So the this one, the approach that we went with here is hash map with doubly linked list. We know that mainly hash map, right? So the time complexity would be big O of 1 for both this one. Just give me a second here. For both the operations put and get here, the time complexity would be for the get and put operation will be big O of 1. Why? Because we are making operations of map like get, set and delete, which have average of big O of 1 time complexity. So the overall time complexity would be here big O of 1. So what will be the space complexity here? The overall space complexity would be here big O of n. Why the space complexity here would be big O of n? Because n is the cache capacity, right? To store, we can store up to n key value pairs. So the overall space complexity would be here big O of n. The time complexity would be big O of 1 and the space complexity would be big O of n. I hope the solution is completely clear. For now, this is it. Thanks for watching, guys.